and welcome to all the listeners. This is OP Radio. I'm your host, Mac. I'm a content strategist at OP Labs. If you're new to OP Radio, this is a Twitter space / podcast that we hold every week, talking to builders in the Optimism ecosystem. And super excited to have the guests on today. I'm going to go ahead and let them introduce themselves. Why don't we start with Tim? And why don't you just, introduce yourself however you want, and maybe, your name, where you work, and what you do.
Yeah, right on. My name is Tim Karstens. I'm a software engineer and former algebraic geometer working at RiskZero. I get to work on all the fun stuff. That's there is no domain. It's all the domain.
Tim, that sounds algebraic. What did you call it? Algebraic geometer?
Geometer, yeah.
Geometer. Okay. But you don't recognize the Smashing Pumpkins song.
I know, troublesome. I'm going to blame the audio compression because those vocals are distinct.
Let's do that. Let's pin it on the audio compression. Thank you, Tim. And Steve, go ahead and say hello to the folks on OP Radio, if you would.
Hi there, OP Radio. My name's Steve Pack, head of product at O1 Labs. I have a background in software engineering, entrepreneurship, and product management. Most recently, I was at Cloudflare for 5 years. And before I joined O1, I guess I'm like a lot of folks who make this journey of wanting to, work during the day full time on the things that they're passionate about that they used to only work on in the evenings and the weekends.
I love that, Steve. That describes my journey in crypto exactly. I was spending so much my free time in the space that I thought, hey, why not make a career out of it? So very cool that we get to do something we love so much. So the topic of today's space, I'd like to lead this off by talking about something called a foundation mission proposal. And I promise this will make sense once we get to the end of this. So what is a foundation mission proposal? So this is a proposal to optimism governance. And what distinguishes these proposals is they're for specific initiatives in the Optimism Collective that achieve a specific intent. So you can think of them as like a directional intents. You can think of as like directional goals that help the collective align and work together. And you can think of these foundation missions as an arrow aiming at the target or intent. Just as there are many paths an arrow might take on its way to a target, there are many different foundation missions that might accomplish an intent. And foundation missions are the most formal type of project proposal in the Optimism ecosystem contributions repository, and they typically come attached with grants for the completion of the mission. So in voting cycle 13, there were 20 applications to do these foundation missions, and 6 of those were actually selected and approved by the Optimism Foundation. One of those foundation missions was to build a zero-knowledge proof system for the OP stack. And our guests today represent the 2 teams that were selected, both RiskZero and O1 Labs, hence the topic of today's space. I'd like to lead this off, guys. Start pretty broad here. What is a zero-knowledge proof? I think you two are uniquely qualified to answer. I'll leave it up to either one of you. Do either of you want to take a crack at this pretty daunting question?
I can go, Tim, and you'll probably be more detailed than me. So I'll do the high level. Hey, and Mac, I might just intro who O1 Labs is so people understand like why I'm here answering this and probably Tim wants to do for RiskZero. So quickly, O1 Labs, we're a blockchain technology company. We incubated the Mina protocol. It was the world's first zero-knowledge blockchain, went mainnet in 2021. And we also incubators of O1JS, which is our simple but powerful ZK-based framework for building ZK applications in TypeScript that run in the browser. So, a long lineage there of zero knowledge, hence why we were, interested in this and this grant and why we have all of this sort of ZK knowledge within the company. So my version is zero knowledge proofs are a way to prove a statement without giving anything away about the statement. And, that's sort of high level enough that you can sort of wrap your head around it, but maybe so high level that's not that easy to actually understand why they're useful. And so I'll give 2 reasons like why they're useful, and then hand over to you, Tim, for maybe the more crypto side of it, to like prove a statement is true without revealing anything else. So, any of us who transact on a blockchain today, as you know, you can go click on a link to, a blockchain explorer, see the address from, the address to, what the amounts were, like, inputs to the smart contract, everything's public. And so zero knowledge proofs are a way that blockchains can be certain that an account, say, controlled an address, had a certain balance, sent it to someone, that was also a valid address, but not share all of those details, but still be able to prove to other validators that this transaction was valid. And so, in summary, privacy. It enables privacy on the blockchain, which is, something that we've all wanted in Web3 for a long time, but, is only there to varying degrees. But the other thing that, like, what is the zero knowledge proof that's more relevant, I think, to this is because of that statement that it allows you to prove that a statement is true without revealing. One thing it allows you to prove is that some code ran. And, there's some sort of constraints about what type of code and how you have to run it. But essentially, a zero knowledge proof can prove that some code ran and that others can verify that with absolute cryptographic certainty that this code ran just the way it's meant to. No, there was no funny business. And so when it comes to providing trustlessness in blockchains, that property of being able to prove that something ran is really key. And so I'll stop there and hand over to you, Tim.
I think that was a fantastic take on what zero knowledge proofs are all about. So I'll intro Risk Zero for a sec, and then I'll kind of give how I think about zero knowledge proofs, ZKPs as they're sometimes called. So Risk Zero is a relatively newcomer to the space of zero knowledge proofs. Early last year, we released our ZKVM, which is a virtual machine that can run programs and generate proofs that those programs ran. So this is the kind of common theme here in this space, is that, we're interested in proving that a particular algorithm was used to generate a particular output. The way that I like to think about it is that a long time ago, cryptographers figured out these things called digital signatures, which you find all over the internet. You especially find them in blockchain if you want to submit a transaction to any chain, Ethereum, Optimism, any of them. You start by filling out your transaction, and then you type in your password to digitally sign it, and then your wallet will sign the transaction and send it off. And others can verify that transaction really did come from you by performing a little bit of mathematics to verify that signature. That's what digital signatures are about. I look at zero knowledge proofs as kind of a generalization of this idea. With a zero knowledge proof, you can produce signatures from a program's execution instead of from a passphrase. In essence, the program, by virtue of running, signs its outputs. And so that those outputs came from that program. So this is exactly, as Steve was saying, the basis of how you can achieve some privacy in here. You don't have to supply there's nothing about the inputs to that program need to be revealed. You can reveal them if you want to, but you don't have to. And the point, again, is that if you transmit this data to someone, there's a simple mathematical procedure that they can perform on their computer to verify that this output really did come from the program that you allege to have run. That program could be all sorts of things. It could, for example, be the program that generates new blocks for a chain, which, of course, is often how it's used in this space.
So, and why are we talking about this? It's because the OP Stack code base is built to be modular. And so eventually these ZK proofs can be slotted in as one of the proving systems of the OP Stack. I'd like to shift gears a little bit now and talk about I think this is really interesting and a bit of a paradigm shift, the way that these proposals were submitted and selected. And I'd love to hear from Steve and Tim sort of their thoughts on that. So, as I said, it's a bit of a paradigm shift. Maybe if you're used to, working at like a quote unquote traditional company where you're building products that are competing against other products. And here we have this more positive sum sort of system set up here where both O1 Labs and Risk Zero submitted proposals. They were both selected to build a zero knowledge proof system for the OP Stack. And I just want to hear your thoughts, Tim and Steve, on how you guys and everybody at the team there sort of approaches this and how you're thinking about it.
Yeah. So I love that you said, positive sum. I think both Risk Zero and O1 Labs, are quite obviously taking a bet that zero knowledge proofs and just zero knowledge technology is transformative, and it's going to continue to be transformative, and that we're at the day one or like day 0.1. And so, it's in both of our interests as companies to just grow the space, because this is the space where, we have expertise, we already have, products, and we think, it needs to grow. So it's definitely in both of our interests, at that level to both look at this as a positive sum. And, I think it's true. It is. I think specifically for looking at the proposal, like it wasn't automatic. Like when we saw the RFP come through, it wasn't like we're gonna definitely do this straight away. Like we have limited resources. We do a lot of work for the MENA protocol, like a lot of exciting things happening there. But we also have seen just growth of L2 in general, and OP in particular, and call it my Web2 product training or scar tissue, but you do have to go where customers are and where there's opportunity to really take a look at like what the opportunities are. And I think one thing here is the growth in L2 has been amazing. The growth in the OP stack has been amazing. Like Base, sort of, Coinbase, the company with such a massive customer like distribution, like signing up to use the OP chain was just another signal that like, okay, like this is like something we have to take really seriously, and that it was a great opportunity for zero knowledge. And so to go like a little deeper, like we've been looking at like ZK VM for quite a while, and we'd already sort of had like some working prototypes. And what this gave us a chance to do as well was, which I really like from a product perspective, is co-develop that with the first customer. We were looking a lot at like what is the best way to package sort of ZK VMs in a way that like, is it for individual developers as part of an SDK? Is it a centralized service? Is it something else? Is it bespoke? And we were still exploring all of that at the time that the RFP came along. And so this was just a really good opportunity to be laser focused and say, here is a huge like chain with a lot of growth that like has a very distinct need today to utilize zero knowledge proofs, and specifically in a ZK VM. So it was just a really good opportunity for us. And then this last thing I'll mention, like just the fact that the OP stack being so modular, like also meant that like it was much easier to say like slot in, the zero knowledge layer. And I'm sure we'll get into more details about exactly what it is and how it works. But like all of those things combined just made it like made it the right choice for us.
Love that, Steve. And just to reiterate, it sounds like you made the astute observation, the wise choice to just kind of move to where the ball is going. I was on layer2beat.com the other day and was just looking at layer 2 transactions. And yeah, that chart's pretty much just up and to the right. So it's a pretty clear trend. So I think that makes a lot of sense. Tim, I'd love to hear your answer as well.
Yeah. So I think that when we saw the Foundation mission request for proposals, we actually got excited pretty quickly about it. Historically, in the old Canon system, Optimism's approach to scaling involved this concept of having these fault dispute protocols. And mechanically, the way that this worked is that there is a program called OP program that is compiled for the MIPS architecture, and it was used to generate blocks. And the idea is that if there was a fault somewhere along the way, if somebody had submitted a faulty block, then in principle, you should be able to pinpoint the exact place where the block that they proposed diverges from what the official block builder would have generated. So this is a really mind-bending and amazing thing that involved emulating MIPS instructions on Ethereum, a completely total MadWad architecture that absolutely got the job done. And with the proposal to go to ZK, we got excited right away because we said, here's someone who's already taking advantage of what we might call like industry standard architectures, in this case MIPS, and applying it to problems in blockchain where traditionally we've had custom architectures like the EVM. So this really appealed to us because our thesis when we set out to start working in ZK a little over 2 years ago, we thought that the real holy grail would be to produce zero knowledge proofs for general purpose industry-wide architectures that have industry-wide support behind them, orders of magnitude more adoption than, like blockchain is still very new relative to the rest of the internet, right? And so we were really interested in embracing those kind of standard technologies. We saw an opportunity here in the Foundation mission to do exactly that for weeding L2, and L2 that people are actually building new and interesting experiences on top of. So, the challenge, of course, like Stephen said, especially true in our case, we're a startup. Resources are definitely always a thing that you have to fight to get. But because we were already doing proofs for general purpose architectures, in our case, RISC-V, we said, gosh, if we can't do this, then what are we even here for, right? This is exactly the kind of thing that we want to enable. So we right away, sat down and started looking at ways that we can engage and contribute to this problem. I also want to say a little bit too is about the net positive kind of vibe that's going on. And so, one of my favorite things about blockchain in general, I think this has been true, since the inception of Bitcoin talk forum way back when. There's this notion here that most people are still not yet on chain. The big prize is going to be, when we're talking about having 1 billion monthly active users and a whole bunch of applications besides, day trading. I mean, day trading's fine, but we want to have all sorts of experiences on chain. And, the vehicle for doing that is that you have a bunch of people who are doing open source work. You have a bunch of startups that are picking slices of the problem and making contributions there. And what I've found that's always really been engaging for me in this space is that there really is an attitude of collaboration and what I'll call friendly competition instead of bitter competition, right? In Web 2, I'm quite familiar with bitter competition, but in this space, when I talk to other folks who are working in ZK, even when they're not at risk zero, there's just a tremendous amount of openness and excitement. I think that a lot of us have questions about, where's all this technology going to be in the next 5 or 10 years? How are we all going to get there together? And it's just been a really positive experience. And so we see that very clearly in the approach taken by Optimism with the OP stack of, this generous modular open source approach that allows others to come in and build on top or make changes on particular components and really just explore the space and get it into the hands of users. And as an engineer, there's nothing that excites me more than the concept of building stuff that people actually use. I think that a lot of folks here can relate to that. And the OP ecosystem, I think, is one of the most productive examples of that in action.
Yeah, I'd echo the friendly competition. It is a refreshing thing about our industry. On the additive thing too. Like there was also, when we looked into it like more and more, it did become eventually a no-brainer, even though it wasn't when we first looked at it. And one of those things is the way we approach sort of ZK at the moment at O1 and in the Mina ecosystem is like through like I mentioned O1.js. So we let people build applications that leverage ZK tech in the browser, and it uses what I'd call a sort of a custom circuit approach. And we make it easy to build, but it's people build like very specific apps that leverage ZK, and we think that's going to be like a really great way to leverage ZK. But this is quite different, right? This is like, that instead of writing specific ZK programs, you can just write a program, in this case, anything in MIPS, and execute it, using a ZK VM. And so the thing that like we get out of it too at O1 is not just contributing like to the OP stack and the OP ecosystem and helping to secure the blockchain. We're going to be able to use this in the Mina ecosystem as well and offer now not just the ability to write apps in O1.js, but also, and not today, but this unlocks that path for us to be able to, use this same ZK VM technology to generate proofs, not just for the OP chain, but also for Mina. And so that was another one where it's just like, this is additive. Like this is not zero sum, it's positive sum for the whole industry.
Yeah, that's great. And I was going to say, for both of these teams, like a lot of this work has already been done, right? So that's the very cool thing about this, and that's the beauty of the OP stack. Obviously, there is additive work that does need to be done to integrate the fault-proof system into the OP stack, but it's not like you're starting from zero, right? So that's the beauty of the OP stack. I want to just emphasize something that Steve said earlier about this, and we're going to harp on this because I think it's so important, but this positive sum idea, and I see this time and time again in this space, it's this idea of, instead of fighting over this little slice of the pie, why don't we grow the whole thing? Because we're all going to benefit together if that's the case, instead of just squabbling over this small slice of the pie.
Exactly. I think that was one of the big lessons of the web itself. I remember early in the late 90s, lots of companies positioning themselves to be the technology provider, companies like Sun Microsystems and others whose campuses are now occupied by other companies that, maybe had more of a more positive, we're going to work on this problem, you're going to work on that problem. And one of the key promises of Web 2 was this idea that the web would be a point of integration between all of these different ecosystems. This is in major contrast to what the internet was like for consumers before the web, when you'd have some users on CompuServe and other users on Prodigy, and never shall the two meet, right? This is what the pre-web experience was like for people. But with the web, this idea of like, no, people live these giant lives. They're involved in lots of different activities. Those activities will be served by lots of different providers, and we need to make sure that they're all interoperable and compatible. And in doing so, we will, some people say, grow the GDP of the internet, and it'll just work out better for everyone. And I think that's exactly where blockchain is at today.
Yeah, it's this abundance mentality versus one of scarcity. And as I said before, you guys have both mentioned that a lot of the work that you'd already been doing and would have been doing anyway, you're able to utilize here. That being said, though, like this was a commitment for both of your teams for precious time and energy and resources. So I'm sure you did your due diligence on the OP Stack code base. I'm curious to hear from both of you if in that process, sort of, if you had any learnings or takeaways after taking a deep dive into the code base.
Can I go, Tim?
Yeah, so I was actually fairly new to the OP Stack when the proposal came out. There were a few folks that I knew from the labs from last year, and I had a general sense of what they were doing. But of course, when we saw the proposal, and myself and a few other coworkers said we have to get involved in this, the very next step was, okay, how, right? Like, can we get our head around the requirements and the needs and the standards and the protocols and the existing tech and all these other things? Which is, I'm not supposed to admit this as a principal engineer. I'm supposed to pretend that I know everything, but of course I don't know everything. And a big part of, actually going out and building real stuff for real users is to actually get your head around their problems. And what I especially appreciated about the OP Stack was, one, the quality of the documentation and specifications. I think it took me an afternoon to read through all the relevant things and understand how the sequencer worked, understand the minor differences between, the EVM execution in OP versus Ethereum, like how gas is handled, stuff like that. So the onboarding was really quick, which I appreciated, and isn't always the case in less mature systems. And then the other thing that was really handy, specifically about the OP Stack, is that there's several implementations available that you can kind of crib notes from. And so, of course, for Go programmers, OP, the Go full node is itself like an excellent resource. But myself, I'm more of a Rust guy. And sure enough, there's actually plenty of high quality, more recent implementations written in Rust. And so, a couple days later, it's like, oh, okay, yes, I can see exactly how this flows and, estimate how complex is this going to be to ZK prove. And it was actually pretty straightforward to do that technical due diligence. And I think that is actually a pretty major differentiator, especially for a modular ecosystem like OP.
Very interesting. And shout out to the OP Labs DevRel team for that documentation. I'm sure they'll be really glad to hear that, Tim.
Yeah, nice. Yeah, I guess I'm one stack frame up from Tim in terms of how deep I went on the code itself. That was our architects and engineers at O1 Labs. But what was clear to me from the start, it's an open source framework. Like O1 is an open source company at heart. O1JS is open source. The Mina protocol is open source. That is obviously the type of area that we work. It felt like a really good culture fit. So that part was easy. I think the signals of just the OP stack, like, what is it? Every day there's a new chain launched on it. So the market is talking about sort of that it's a good way to build layer twos. That was clear. I guess one thing different for us and maybe slightly on the friendly competition, RISC-0 already obviously invested a lot in RISC-V. And that was another thing about this proposal that Canon was a MIPS program. And so that was, nice for us that it was okay, here is, another instruction set architecture that can benefit from a ZKVM. And as I said before, a customer and an ecosystem that wants it. And so, yeah, the due diligence came back with a big tick.
Awesome. And I'm not sure how much research both of you have done into the other team's proposal, but I'm wondering if you can tell me what in your mind are the major differences in these two proposals, and along with that, maybe what are the similarities?
Mac, I reckon we should take a moment to describe what the RFP is and what the proposals are meant to do, because I don't know if that's always 100% clear to folks.
Let's do it. Do you want to take a crack, Steve?
Yeah, okay, I'll take a crack. So, optimism, an optimistic roll up. So the the way users experience that is like, low gas fees, like fast confirmation times. But the other way they experience it is like long delays in being able to like withdraw funds or to bridge those to L1 or to other chains. And that's, the sort of, I guess, famous sort of 7-day waiting period. And what that is giving folks a chance to run the fault proof program, to be able to prove like there was definitely, no fraud, no invalid state transitions introduced. And like obviously OP as a like user focused organization wants to like just improve that experience, reduce the withdrawal time, like allow liquidity to flow freely, allow tokens, like whatever it is, like that you're doing on the blockchain, for that to be able to move around more quickly and more freely. And so this, like what this RFP does is, instead of like having us all wait to run the fraud proof program, instead we're able to say, here is a zero knowledge proof that gives you cryptographic mathematical certainty that there was no fraud because we've run the program and here's the output and it is solid. And so this puts us on the pathway and puts Optimism, and OP Stack chains in general on the pathway to, to be able to get closer to this sort of like instant withdrawals, instant bridging, really sort of, I think, getting closer to what the ultimate vision is, and that's why it's so core. And I just wanted to make sure that we were calling that out before we go into the details of the proposal.
You're so right. And thank you for that, Steve. You're making my job easier. That was a great description. I wonder now if we could speak to maybe the similarities or differences in your mind with these two proposals.
Yeah. Okay. So similarity, it's it's a ZK circuit. In this case, it's a circuit that represents a virtual machine. And so, it takes some inputs, such as like a hash of like what the block is on Ethereum that represents like the current state of like the chain, like lots of lots of mathematical proving, and then you get a proof that says, these state transitions are all valid. There was no fraud here, and then that proof goes to L1 Ethereum to verify. So at some level, it's the same thing, right? There are inputs, a ZK circuit representing a VM, proof to the L1. Within that, there's a lot of detail, but I think at the core, they're similar. So I'll stop there. Tim?
Yeah, I think that at the core, they're extremely similar, right? Exactly as Steve said, the idea here is that you want to go ahead and generate a ZK proof that a given block was constructed correctly. And the moment that proof is verified on the L1 on Ethereum, there's no need for any kind of remaining dispute resolution window or anything else. Basically, at the point that the block has been proven correct and verified on chain, that's it. It's just good. And so this is the big similarity. I think that the only difference here is MIPS versus RISC-V, which itself is a very tiny delta. RISC-V is often described as being, sort of the next version of MIPS. There's a lot of architectural similarities. In our proposal, so the RFP itself specifically asked for the ability to run the OP fault program canon from within a ZK VM. And it said, we want to do this with an industry standard architecture. MIPS is an obvious choice. It's already supported by the Go language. And we actually took kind of a sort of a risky departure from that. We said, that sounds good. That approach would totally work. But the Go language does not support our VM presently. So we're a 32-bit RISC-V, and they don't support 32-bit RISC-V. But while the proposal was going out, internally, we were at the start of a related project called Zeth. Zeth is a zero-knowledge prover of Ethereum blocks based on REVM, Ethers, Alloy, and a lot of the other crates that are common in the Rust Ethereum ecosystem. And so we already had that work in flight. And we said, one of the key benefits of the OP stack is that it's extremely EVM compatible. It's probably the most similar to EVM of any of the things that are not actually Ethereum itself. And the differences are all exactly the differences that are sort of forced by, being an L2. You have to handle gas differently, things of that nature. You have to have, built-in support for bridging, et cetera. So in our proposal, we said, instead of running the Canon fault proof program, why don't we add support for the OP stack to our Zeth prover? It's a minor set of differences from what it takes to prove an Ethereum block, and we can build on top of that. And in doing so, kind of contribute to the diversity of options in the ecosystem and take advantage of this existing open source work. So I think that's probably the biggest difference is, that Go versus Rust kind of mentality.
Yeah. So to sum that up, both of these arrive at the same destination. Obviously, there's always more than one way to climb the mountain. So maybe some differences in the implementation here, but ultimately achieving the same end.
Yeah, I think when we saw Risk Zero's submission, honestly, we chuckled a little bit because the RFP was, hey, prove Canon, and we summarized the Risk Zero's approach as, hey, actually, here's something more efficient. Let's prove this instead. And that's what you get, when you do an RFP process, right? Like this. And I think Carl from the Optimism was sort of saying part of this is a design exploration, right? What are the different ways to solve this problem? And so we are approaching it from sort of different angles in terms of what is being proven, what is the instruction set architecture that's being proven, and then how we each go about optimizing each of our VMs to produce the results sort of cheaply, whether it's time or money, gas, etc. So yeah, yet another positive sum of the process.
Yeah, exactly. I think that's a great benefit of this proposal process, and it goes back to that spirit of friendly competition that we talked about earlier. So very cool. As my old firefighting captain used to say, 2 is 1 and 1 is none. So, the more the merrier. I'd like to transition now. I think I'd like to talk about maybe some of the common misconceptions about ZK. I don't want to spend too long on it, but one of the things that I often hear about ZK is that while it is ideal, it's maybe not quite ready yet. Tim, do you want to speak to that? I know you had some comments on that.
Yeah, absolutely. When I got into the space early last year, one of the first questions that I had, for the team at Risk Zero was exactly this, can you actually use ZK to do anything? Back when I was in college, ZK was something that you would learn from the professors who focused on theory, not practice, right? And I was astonished to see, just how much development had taken place in zero knowledge, applied zero knowledge proving, especially over the last 5 years or so. And really the story goes maybe 15 years, but in terms of actual software you can download and play with on your computer, let's pretend it's 5. And so today we're now in this spot where every year, breakthroughs are taking place that are changing, and increasing the set of things that are possible, reducing the barriers to entry and moving closer and closer to being a technology that's, getting easy to integrate into existing ecosystems instead of being something that you have to be very clever to use in very limited sorts of ways. And so, whereas a few years ago, zero knowledge proofs required very carefully chosen problems running on very carefully built computers with extreme hardware requirements. We're now at a spot where there still is a place for large computers. There's also a place for clusters of smaller computers. And increasingly, we see this in some of the work O1 is doing, there's also a place for user devices, mobile, browser, etc. One of the things that I think about a lot is, where is this all going to be in 5 years? I feel like right now we're in this moment where the derivative is very high and change happens super rapidly, and it's exciting to think about what kind of performance we're all going to be experiencing, as we continue as a field to develop more and more of these improvements and better insights into how these proofs can be generated.
Yeah, it's super exciting. Steve, do you want to address a little bit more about I think that was a great synopsis of sort of the present of ZK proofs. Do you want to talk maybe about what might be coming on the horizon?
Well, I'd add a few things to the that misconception actually as well. We spend a lot of time in the Mina ecosystem, and Mina went mainnet in 2021, and it's the same Kimchi proof system. That's the name of our proof system. That's at the core of the ZK VM. That will produce these proofs for Optimism. So it's been mainnet for years, right? And so that sometimes gets lost. That there is lots of advancement in ZK and new approaches and new performance benchmarks. but like it's actually been around longer and in production, I think, than sometimes, folks realize. So like that's one. Another is I agree with Tim on this sort of like the derivative is high. I feel like you watch a talk from a year ago and they talk about like what's going to be true in 5 years, and then at the same conference the next year that 5 year vision is already there. Like just the whether it's the sort of the size and like of the proof, or the efficiency, and things like folding, recursion, like all of them, like they're coming fast, and so it is sort of hard to figure out exactly where things are going to be. I like even one example of this that I love is like I've heard Vitalik talk about like the sort of, what does he call it, the like sci-fi version of Ethereum, where it's like everything is snarked, and whether you're on your watch or your phone, you just like go to some like site, like some DApp, and it downloads a couple of snarks and gives you a green tick that tells you like, yes, you're at the tip of the chain, it's valid, like you're good to go, and any device could do that. So small plug to Mina, like that's possible today to actually verify Mina's proof in a browser. And so like this sort of sci-fi future, like yes, it will take longer for that to get to all chains, and especially Ethereum, they have to move slower. But like this sort of future where like low powered devices can utilize ZK to very quickly be sure that they're on the canonical blockchain, that everything is good to go, and they're now ready to transact privately, freely, like with low cost, like that's coming in real hot, and that's exciting, and that's part of what we're doing right with this project.
I'm ready, Steve. Give me my OP ZK red watch.
Yeah,
I'm ready. Steve, I wonder if you wanted to talk a little bit before. I feel like we're getting close to winding down here, but I think you wanted to mention a little bit about the different approach that O1 Labs is taking, and sort of your view of the world, how it might differ a little bit.
Yeah, cool. I appreciate that. I think I guess there's a few ways like we look at ZK and proving. There's sort of the like, are you building a custom circuit or are you doing a VM? Are you proving client side or are you proving server side? Like there's lots of other ways you can slice it. And so with this work, like it's our sort of foot in the door for like server side VM proving that we can prove any MIPS program, and Cannon's going to be the first example of that. And that will start out settling to Ethereum because that's what this project is for. But we also see these proofs being able to settle to Mina as well. And this is the like the glorious nature of modular software, that the same proof system that secures Mina, like we can use it for both purposes. But the other side of it is like writing apps, right? And this goes back a little bit, I think, the misconception about ZK maybe, that it's true when you type like ZK in a browser and like try to understand as an application developer how to use it, like you straight away like, and this is from a like a non-cryptographer, non-mathematician. I see a lot of some symbols and sigmas, and it's like, oh, okay, this isn't for me. This is for like somebody else. And it's true that like a lot of like writing custom ZK circuits and ZK apps like is difficult in a lot of languages. And we took a bet a long time ago that was like a twofold bet, which was one, that like we need to make ZK accessible for like a wider set of application developers. And so that's why we chose TypeScript, that TypeScript and JavaScript developers, all 10 million of them, can use like O1.js to build ZK apps, and they'll run in the browser, and they'll settle to Mina. But that's like, that was sort of that was and is our view of the world, that you need to make ZK super approachable, and and we do it that way through language choice and in the browser. But that's the client side. That's the sort of like, you want to write an app, you want it to run on the user's device. And this project is about more like server side VM based proving. And we think both are going to be absolutely huge. They're both huge markets. They're really just getting started. And yeah, like excited to be playing in both.
Well, we're super excited to have both of y'all and both of your teams join the Optimism Collect. I want to thank you both so much for your time. Before we close this out, is there any parting comments you'd like to give to the folks on OP Radio?
Tim?
Sounds like we said it all. We covered it all.
Yeah. No.
Go ahead, Tim.
Yeah. I just invite folks to check out the work that we're doing with the Zeth Ethereum block prover. You can find it on our GitHub, risk0/Zeth. And if you take a look in there, you'll also see the branches for our work on optimism, including the ability to build optimism blocks and the ability to provably read from the OP sequencer.
Awesome. And yeah, thanks for having us. You can find on labs at o1labs.org or search for O1JS in NPM or GitHub. We're formerly known, the library, as SnarkyJS, by the way. So if you can't find O1JS while SEO catches up, check out SnarkyJS. And yeah, thanks for having us, Nick. Mac?
Absolutely, my pleasure. And Steve, you dropped out a bit when you dropped that URL. Do you just want to repeat it so we make sure folks hear?
Sorry, search on NPM or GitHub for O1JS, but it's a recently rename. We were formerly SnarkyJS. So if the SEO hasn't caught up, you can find us that way.
Awesome. And for my part, if you want to get involved with the Optimism Collective, as we've mentioned, it's all open source. It's all available to you. So you don't have to do one of these foundation missions either. There's a lot of different ways to get involved. I'd encourage you to go to github.com/ethereum-optimism/ecosystem-contributions. Sorry for the length of that URL, but that's our ecosystem contributions dashboard. And it's a great resource for anybody who wants to get involved building in the ecosystem. Tim and Steve, thank you once again so much. I hope you have a great rest of your day. Thanks everybody for tuning in. Don't forget to like and subscribe to OP Radio on YouTube, Spotify, Apple, Google, etc. Thanks, guys. Stay optimistic. We'll see you later.
Thank you. Take care, brother.
Thanks all. Yeah. All right.